Two small steel ball bearings have the same radius and they are located 1.2 meters apart. One has a charge of positive 3 microcoulombs, while the other has a charge of negative 5 microcoulombs. What is the electric force they exert on each other? So first we're going to convert microcoulombs to coulombs for both charges. So positive 3 microcoulombs times 1 times 10 to the negative 6 coulombs over 1 microcoulomb equals positive 3 times 10 to the negative 6 coulombs. Negative 5 microcoulombs times 1 times 10 to the negative 6 coulombs over 1 microcoulomb equals negative 5 times 10 to the negative 6 coulombs. Then we're going to use Coulomb's law, where F of E is the electric force. K of E is a Coulomb constant, which is 8.9875 times 10 to the 9 newtons times meter squared over Coulomb squared. Qi is a charge on object I, so Q1, Q2. And R is the distance between the charges. And keep in mind the units for Newton is 1 kilogram per meter over second squared. So 8.9875 times 10 to the 9 newtons times meter squared over Coulomb squared times the absolute value of positive 3 times 10 to the negative 6 coulombs times the value of absolute value of negative 5 times 10 to the negative 6 coulombs over 1.2 meters per second meters squared, which gives us 0.09361979166 newtons. The steel balls from the above question are brought in contact with each other and then replaced to their original position. What charge does each ball have now? In the above question, you found the force between the two ball bearings. In addition, you will notice that one ball bearing has a charge of positive 3 and the other has a charge of negative 5. The net charge on both ball bearings would be negative 2 microcoulombs. The net charge is important for the next question. Keep that in mind. When the two ball bearings touch each other, they reach an equilibrium and share their charge. When the ball bearings are returned to their original position, they split the net charge of the negative 2 microcoulombs. Each ball bearing will now have a charge of negative 1 microcoulomb. So now what is the electric force the ball bearings exert on each other? So we have 8.9875 times 10 to the 9 newtons times meter squared over Coulomb squared. And we're going to multiply it by the absolute value of negative 1 times 10 to the negative 6 coulombs times the absolute value of negative 1 times 10 to the negative 6 coulombs over 1.2 meters squared, which gives us 0.0062413194444 newtons. Thank you, and I hope you enjoyed.